Now I want to talk to you about how you can use dot notation to reach deep into a document and add an index to something that's in a sub-document of the main document. And also doing this with things that are arrays. So combining multikey with dot notation. This is a pretty cool feature of MongoDB. It's a little tricky to explain how it works and may not work exactly as you expect. So let me show you some examples. All right, I'm back in the Mongo shell now, and I'm going to look at this students collection once again. So db.students.find1. This is the same collection we looked at in the previous lesson. And it has these documents that have structure where there's a student ID, and then there's a scores array. And the scores array has a bunch of documents as elements of the array, where each document has a type, exam, and a score. And there's also a class ID. So let's say we wanted to index on this score itself. We can do that. The call would be as follows: db.students.createIndex scores.score is 1. That's how we would do it. That's where we'd create an index that would index this array and this subpart of this document. And I did this off camera because it took about 15 or 20 minutes to create this index, because there's 10 million documents, there's 4 elements in this array, and it took a long time. So you can see what indexes are on it, on the collection. We'll do that right now. And if you call db.getIndexes, you can see there are now 2 indexes on the collection. One of them is on underscore ID, and the other one is on scores.score, which is our multi-key index. So what can you do with that? Well, first of all, you could search for records where any score was above a certain value. So let's look what that query looks like. This will find everything where scores.score is greater than 99. And I'm actually more interested in understanding what the query optimizer does with it than actually seeing the results. So I'm using explain to return that information. Let's do that. And if we did that query, you can see that it's going to do an index scan. It says right here, winning plan included the scores.score index. In the forward direction, it looked for things where scores.score was between 99.0 and infinity. And that's how it retrieved this information. And if we wanted to see that information, we could just remove the explain part of this, and then we'll get some documents back where there is at least one score above 99. Let's pretty print it so we can see that more clearly. And you can see that in this case, it was the homework that was above 99. So what if we wanted to find people that had an exam score that was above 99? How would we do that? Now I'm going to show you the query, and then I'll show you a query that I used before I looked into it more carefully that turned out to be wrong. I think it's an interesting example because it's easy to get confused about this. So the query that would search for all the students where an exam score was above 99 looks like this. And it uses this LM match operator. So we're going to go through this very carefully. It's actually being run with explain right now, but let's look at it. So we're trying to inspect the scores array inside the document. And then we want to find a document which has an element of the array that is of type exam and a score greater than 99.8. And to do that, we use this operator called LM match. And what LM match does, and you can look this up in the documentation, is it matches documents that contain an array field with at least one element that matches all the specified query criteria. So in other words, there might be more than one element, there might be more than one exam in this array that match this criteria, but we're going to make sure that we match at least one with all of this criteria. So it's looking for an element that's of type exam and score greater than 99.8. And if we do that, let's first just get the result so we can confirm that works. So I'm going to pretty print the result. We see that we get something that has an exam score above 99.8. Works perfectly well. It's very nice. I wonder how many records there are, just out of curiosity, that would satisfy this criteria. And the answer is that there are 20,278 students that satisfy this criteria of having an exam score greater than 99.8 in this somewhat random data set of 10 million documents. All right, well, what does the explain output look like for this? Because that's sort of an interesting question to me. All right, let's run this with explain now to see what the query optimizer is going to do to satisfy this query. And to do that, I need to remove this count at the end. I just need to do an explain, tell it that I want to see what it would do with this find command. So I'm going to run that, and it's pretty interesting. We're going to go over explain in more detail, but you can see there's a lot of information here. But the winning plan, and it's kind of easier to read this from the bottom to the top because actually you can't quite tell, but this is the first thing it runs, I believe. It says that first it runs a query on scores.score being 99.8 to infinity. Okay, that makes perfect sense because that's what the index is. So it can't do any better than to look at the scores.score key. And then after that, it runs the output of that, this is an index scan, into the next stage where it finds all the documents that satisfy that criteria, which is probably 10x or 4 or 5x the number of documents that would have an exam of that score. And then it runs the LM match. And it says, you know what? I want to find something with a score that's greater than 99.8 and a type that's exam. It calls this a fetch. I don't believe there's anything special it can do here. I think it actually iterates through every single document and inspects them. And we could confirm that by running it with value true and let it execute the query so we know how many documents it examines. And the answer is that it examined, so right here we can see the explain output. It's a little bit hard to read on the screen, but again we have the winning plan information. It's exactly the same as before. But now we have some additional information called execution stats. And we just kind of go through here and look at what's interesting. And then we can see that it returned 20,000 documents. Okay, that makes sense. But it examined 80,000 documents. Wow, okay. And you know what that number is? It's probably the number of documents that have score above 99.8. So let's just confirm that that's true. Score greater than 99.8. Give me a count of those. And there are 80,054 documents that have score greater than 99.8. And it examined every single one of them for this query. Let's see where we can find this information. Here are the execution stats for the query. And you can see it examined 80,054 documents to return 20,278 documents. That's because the way MongoDB went through this query is it used the index it had, which was on scores.score. And then after that, it just essentially did a scan of everything that resulted to do the LM match part of it. All right. Now, what mistake did I make when I was setting this lesson up and thinking about it that turned out to be wrong? And the answer is I tried to use this query. I won't go through it too carefully, but I want to show it to you because it confused me. All right, here's the query I tried to use to get the answer of every student that had the exam above 99.8. I tried to use the AND operator and said, you know what? I want to find things where scores.type is exam and scores.score is greater than 99.8. And when I did that, you know what I found? I found documents that look like this. I found documents where there is a score greater than 99.8, but it wasn't for the exam. Really interesting, huh? So actually, if you use this AND operator, there's no guarantee that when it finds a document that satisfies this criteria without the LM match part, that it satisfies this criteria in the same subpart. It might be a different part. And this really comes out when you look at the explain output, actually. The explain output helps you understand the way the database interpreted this query. And once you see this explain output, you're like, oh yeah, of course, makes perfect sense. So the explain output said, here's what we're going to do. Here's the winning plan. Okay. It said in the first stage, in this lowest level stage, I want to find everything with scores.score above 99.8 and pass that up to the next stage. And the next stage should look for things with scores.type equal exam. Oh dear, that's not right. Because basically it's returning all these documents, returning a huge number of documents from this stage that have, well, we know how many. There's like 80,000 students have 99.8 and above. So first it does this query, finds all the students with any score above 99.8. Then it passes it to this next stage and says, now find me all the documents where scores.type is equal to exam. And that's not going to work because that is going to give you things where the score was not for the actual exam. Now compare that output to what output we got for the correct query with the LM match. When we use the correct query for this, look at the output. It's very different. In that case, the first stage of the query did the exact same thing. It looked for things with scores.score above 99.8. But in the second stage, we didn't just look for things of type exam. We looked for an element match where both conditions were true. Where the score was again 99.8, we reaffirmed that this was true for the document and that the type was exam. All right, that's a lot of information. But I hope that helps better explain, no pun intended, how that works. Okay, it's time for a quiz. Suppose you have a collection called people in the database Earth and documents in the following form. And you can see the documents here. What would be the command in the Mongo shell to create an index on company descending? Please type your answer right down here.